Alright, we've talked about solving quadratic equations that had real and rational or irrational roots. Now what we're going to talk about is quadratic equations that will end up with imaginary roots. So if we look at this problem, we first start off by having to add the 2 to both sides to get it equal to 0. Make sure that it's always equal to 0. 10x squared plus 4x plus 2 is equal to 0. Now, this is not factorable. There are not two numbers that multiply to 20 that add to 4, so we know it is not going to be factorable. So what I want to do is use the quadratic formula. Besides, it tells me to do that in the directions anyway. So we say negative b plus and minus the square root b squared minus 4ac all over 2a. So a negative version of b in this case is negative 4 plus and minus the square root of b, which is 4 squared, minus 4 times a, which is 10, times c, which is 2, all over 2 times a, which is 10. Now I have to go ahead and calculate this stuff, so I'd say negative 4 plus and minus the square root of something over top of 2 times 10 is 20. Now that something on the inside is pretty easily calculated. We say 4 squared is 16 minus 4 times 10 is 40, times 2 is 80. And 16 minus 80 should be a negative 64. So we have a negative 64 right there. Now, usually you would say there are no real solutions to this, and that is the case. There are not real solutions. There are two imaginary solutions to this. But since we know how to deal with imaginary numbers, let's deal with it. Square root of 64 is obviously 8. Negative 4 plus and minus 8 over 20. But it's not square root of 64, it's square root of negative 64. So I have to say 8i. Now, that is all the difference between the imaginary roots and the regular roots. So what I want to do now is just simplify. If I say 4, 8, and 20, what goes into all three of those things? Well, 4 goes into them all. So negative 1 plus or minus 2i all over 20 divided by 4 is 5. And these would be my two solutions. I can't simplify it anymore. You cannot combine a real number and an imaginary number, so you just leave it as these two complex roots that are here. Just another example real quick. I don't know, I'll find one that looks, I don't know, somewhat difficult. Yeah, that one looks maybe a little bit more difficult. Let's go ahead and subtract the 11x squared and subtract the 12 from both sides in order to get this equal to 0. And that'll get me 2x squared plus 7x plus 2 is equal to 0. Now obviously this is not factorable. We cannot find two numbers to multiply to 4 that will add to the 7, so we have to use the quadratic formula again. Negative version of b is negative 7 plus and minus square root. b, which is 7 squared, minus 4 times a, which is 2, times c, which again is 2. All over 2 times 2. There's a lot of 2's in that problem. Now what we want to do is calculate. This is negative 7 plus and minus square root of something over 4. Now the square root of something is this 7 times 7 is 49 minus 4 times 2 is 8 times 2 is 16. Now this is going to be nice because this is not going to end up with imaginary roots, because when I subtract 49 minus 16, that is going to be 33. And 33 is not an imaginary number situation because it's positive, so we don't have to worry about the imaginary roots in this case. What is also great about 33 is the fact that the only numbers that multiply to 33 are 3 and 11. So there's no way that I can simplify this into simplest radical form. You can't combine these guys. This problem is done.